Yeah, thanks so much for having me today. I usually do this presentation or I've done this in about like 45 minutes, so I'm going to move through this really quickly. Um, but the name of this kind of presentation is called Don't Judge a House by Its Cover, telling a different story about where buildings come from and why that matters. So I am the founder of Cross Cabin Build and Supply, and our mission is to bring the beauty of natural materials into architecture in Texas and beyond. Feel nature at home is our kind of tagline, kind of mission. Okay. So we sell natural, healthy building materials. A lot of things we'll talk about today. We represent across the country. So please reach out if you have any questions. Here's my email. Here's my Instagram. I also do consulting. I'm a CPHB in the FIAS system. All right, so kind of a thought exercise to start this presentation. So, how do we tell new stories about how people can understand and value buildings? And the passive house movement, in a way, is telling a new story about how we kind of understand and value what buildings do. And a great story is something that can make you laugh, make you cry, lift your spirits, and spark curiosity about the world. When I was a kid, Goodnight Moon was my favorite book. There's a picture of me when I was a kid. Um, the wood kind of theme's fun. That'll pick back up. Goodnight Moon. So this book, Material Health and Design Frontiers from the Healthy Materials Lab, at Healthy Materials Lab on Instagram, really good follow. There's an essay in there called Decarbonizing Materials and Climate by Charlotte McCurdy, charlottemccurdy.com. And I took a kind of children's story excerpt from that essay. And so this story is called Ancient Sunlight by Charlotte McCurdy. I like to think about carbon in terms of sunlight. Until about 150 years ago, humans met their needs for light, heat, transport, food, and materials with the energy from the sun. But in the last 150 years, we've built a dependence on ancient sunlight. Fossil fuels are also the secondary energy of the sun, but much more delayed in time. And when we use fossil fuels, either by burning them for energy or extracting and manipulating them into useful molecules, we release that stored ancient sunlight and that stored ancient carbon. I became obsessed with the question of what it would feel like to live in a society that was back in a present tense relationship with the sun. We take fossil fuels out of the long-term carbon cycle and pump them into the short-term carbon cycle. The short-term carbon cycle is what all life lives within and what humans historically use to build our societies. The goal is not to literally decarbonize. The fact of the matter is that we are carbon, life is carbon. In fighting climate change, we need to decide how we use our carbon, which carbon, where we want to take it from, and where is a good place for it to go. So where do buildings come from and why does it matter? So this is the cross cabin project that we'll be talking about today. So thinking about the where do babies come from story. So where do buildings come from? Buildings come from nature's carbon library. And nature's carbon library has three primary branches as it pertains to buildings: farms, forests, and mines. So farms move sky carbon into plant fiber and soil and seeds. And so the carbon building block time frame here is less than a year. So you can kind of think of this as a carbon checking account. So in 3 to 12 months, you can have something like hemp or straw. That is a useful kind of raw material, a useful building block to make buildings with. So forests move sky carbon into trees. And this is kind of like the carbon savings account. And the carbon building block time frame here is 30 to 100 years. So we've got wood fiber, cork, and in 30 to 100 years, you've got a useful raw material that you can use to make buildings, make building products with. So mines move ancient mineral carbon into commodities with a side of sky carbon or carbon emissions. And significant energy is required to extract and process mineral carbon. So this is kind of like the carbon buried treasure. So we got concrete, steel, gypsum, foam, vinyl, plastics, and the carbon building block time frame here is hundreds of thousands, millions of years. So this infographic, when I saw this, this is from the Carbon Field Manual for Designers. Alan Organci is one of the architects and researchers that pushed this forward. But this is a cross section of the Earth's crust. And what it's showing is where a building material comes from in the Earth's crust. And this kind of graph, these tick marks on the upper part, are showing how much um, kind of average emissions you have for certain types of building materials correlating to where they can come from. So over here on the left, we have our plant-based building materials, and then over here on the right, we have kind of a stair step of mineral-based building materials, concluding with fossil fuel-based building materials, where we're going deep into the earth to extract petroleum. So where building materials come, to a large degree, shapes a building's climate impact. So in that mineral-based section, you've got bricks, stone, gypsum, concrete. This is kind of moving from left to right. Mineral wool, glass, metals. And then we have our plastic section. So we've got things like PVC, LVT, polyurethane, latex paint, foams, all these things that are petrochemical derivatives. Back to that kind of story theme, we've got kind of our farms, forests, and mines kind of classifications here. But really in the last, since the 1950s, we had our farms, forests, and mines, but now we have kind of the new plastics addition to the Three Little Pigs plus Barbie Dreamhouse kind of classification of houses. Yeah, so the thing with houses is that houses are kind of like a Trojan horse where they're bringing a lot of different chemicals and compounds into the spaces that we live in and breathe in. And plastics in particular, along with other materials like, asbestos, back in the day, et cetera. These things are materials that can hide toxics right under our noses. So as I mentioned, from Austin, I'm a born and bred Texan. So this kind of infographic from Dow Chemical from the 40s is a really nice kind of distillation of like how a petrochemical process works. So in this case, it's showing how saran wrap is made. So you've got petroleum and then chlorine, brine, and you have all of these different processes and energy that's put in at these different points Working with chemicals at different levels of toxicity. So here's the vinyl chloride monomer. That's the base of PVC, LVT, and this kind of long industrial process that is a really amazing example of manufacturing technology to get to a nice and pretty sort of end final product like Dow Saran wrap in this case. So as it pertains to building, so what happens if I put embodied carbon and health impact of materials first when designing a house? And so in the case of Austin, like asking myself this question as it pertains to the Cross Cabin project. So I asked myself, like, what is our material baseline for a typical home design in Austin? So this is a very common spec house. This is down the street from where I am now. And these are the types of materials that are being used. So a typical solution in Austin would be a concrete slab foundation, stick framed. Insulation is most commonly spray foam. Cladding is typically fiber cement, drywall wallboard, and flooring. We're looking at concrete, LVT, some sort of like polyurethane kind of covered material. So we got almost all minerals with the exception of the plant-based wood frame. So I used to run a farmer's market. This book, Food Rules by Michael Pollan, is a kind of great inspiration for thinking about sort of where things come from. So in that book, Michael Pollan throws out this rule for eating in a way that's good for your body and that is also good for the ecosystems that you're a part of. And that rule is eat kind of real food, not too much, mostly plants. So I thought about kind of recontextualizing that for buildings. So what if we build with real materials, not too many, mostly plants? And so real here, which I'm adding to the Michael Pollan's food rules, but real as in not heavily processed. So like vegetables and wood, not Fritos and foam. And Fritos are delicious, but, or in other words, no home Twinkies. So the approach that I came up with for this project that I'm in right now is foundation using a steel pile and beam system, still a mineral-based product, still high embodied carbon, but we're using a lot less material and it has a high recycled content, very likely to be recycled at the end of its life, even now. And then for framing, wallboard, flooring, and insulation, or insulation assist, we're primarily using cross-laminated timber. And then we have a blanket of plant-based insulation on the outside. So for the wall insulation and cladding, we are using cork, expanded cork. And then for the roof insulation, we are using hemp wool and wood fiber insulation. So this is the wall assembly. This is kind of the mostly plants wall assembly. So we have 2 inches of expanded cork that's acting as our primary insulation and finish. And then we have 4 inches of cross-laminated timber. And this is sandwiching a self-adhered Vapor Shield, Wrap Shield SA air and water control layer. Came out looking like this. Here's a video of the process. So we've got that steel frame foundation. Let's see if I can speed this up just slightly. So here the mass timber panels are arriving on site. Fortunately, in this case, we had a large side lot to stage on. Here you can see we're kind of putting them in place. In most cases, we put that water and air control along the panel prior to placing the panel and then picked up the seams with that same membrane, kind of taping, sort of taping the seams effectively. You can see the level of precision with the fabrication of the panels. So here we're kind of sliding that panel into place. That curved window opening was cut on or cut at the factory. So everything just sliding together. Putting the roof panels on. You can see how thin they are. So that's a 3.5 inch panel. It's spanning 18 feet.
Greg, just a quick question. You
Sure.
said the walls are 4 inches of wood. Is it a solid 4 inches?
Yes, it is a solid 4 inches.
All right, that's great. A little bit later, maybe you can tell us why you opted for that when most are doing, you know, beams and then filling in the insulation on the inside. But anyway,
Yeah,
I'll let you continue. I just thought that was interesting. I haven't seen that before. Thanks.
sure. So what's the actual difference in carbon impact between typical and mostly plants approaches? So up here at the top, if we did a typical slab on grade, so concrete slab, spray foam, drywall, fiber cement, etc., that's kind of our baseline carbon impact for something that's the same size and shape of what I'm sitting in. So that we'd be looking at a 27,000 kilograms of carbon dioxide emitted from a embodied carbon standpoint. If we went to a pure and beam with the same kind of conventional materials, that would go down to 64. And then what we did goes down to 26% of that carbon impact. And then if you include the biogenic carbon storage or the carbon that's locked into the cross-laminated timber panels based on the life cycle analysis report, it would go into a negative 19,000 kilograms of carbon dioxide emitted from an embodied cradle to gate, cradle to factory gate standpoint. So here, quickly, your slabs up at the left. This is the beam calculator that the Builders for Climate Action put out. Really cool tool, really easy to use. It's a Google Sheets based tool. You can see that concrete slab is by far the biggest kind of part of the carbon emissions. And so these are the kind of two conventional approaches. So then with what we did, those helical piles are a lot less than a slab and then even a little bit less than concrete piers. The exterior walls, there's significant carbon storage within the cork, as well as the wood fiber and the hemp. And then the cross-laminated timber biogenic carbon storage is on top of that. So. Here's that LCA that kind of goes over that carbon uptake. So that carbon uptake or that negative carbon impact of cross-laminated timber is based on the amount of carbon out of the sky that is being absorbed through photosynthesis into the wood fiber. So I'll blow through this pretty quickly. So alternate materials that we used on this project, cross-laminated timber. Pros are it is a carbon storing structural, but also a finished material. So everything I'm surrounded with here is mostly cross-laminated timber. So it gives that, and most of the walls and ceiling are unfinished, so it is a natural wood. It's a natural wood surface that's surrounding me right now. So it replaces structural framing and sheathing. It is factory kind of computer fabricated and can replace drywall, paint, and finish floors. Um, it kind of facilitates easier air sealing because everything fits together like a big piece of furniture. And the fact that we have, no cavity insulation, that it's all continuous insulation on the outside, it helps replace relying on materials like spray foam for cavity insulation or for, air sealing, even though, I mean, nobody here is going to be using spray foam as a primary air seal, I'm guessing. Um, so yeah, cons across laminated timber. There's complexity of the carbon accounting. The panelized approach requires a different design and construction process. And cons are also it requires careful structural optimization and planning to be cost competitive. So yeah, panel has a major axis and a minor axis. You get a shop basically a shop model with all the pieces that comes from the fabricator or the panel manufacturer. This is what that looks like when it was all put together. Very, pretty much what I'm sitting in right now. Yeah, here's that carbon sequestration process. So it's during that growth that you get that carbon storage, and it can outweigh the carbon impact of manufacturing and transporting the wood. That carbon storage will only fully get released when wood decays at the end of its life. So, tree grows. If you harvest that wood and insert a building there, you're delaying this eventual kind of decay of the wood when that stored carbon is released back into the atmosphere. That's part of the natural carbon cycle of a tree. So alternate materials, steel helical piles. Like I said, I'm going to move through this fast. Fast install, potentially single day. It's recyclable material. Um, and then the greatest opportunity for reducing embodied carbon after reducing concrete is insulation. So alternate materials, Amarine expanded cork insulation. Pros are it's a carbon negative, completely non-toxic material. It is literally just 100% cork bark. It is a unique cladding and almost completely unique cladding and insulation in one material. Biggest cons are really it's new and different. I'd never seen cork in person before using it on this project. Yeah, again, totally all unique, all-in-one insulation and cladding. There's no sealer needed on the exterior. Cuts with regular wood tools. Cut edges match factory faces. It's the same material all the way through. It's very affordable for interior feature walls. And then it's an excellent performance and aesthetic value for exterior cladding when you consider that it's also your continuous insulation. So why cork? Cork, after it silvers, kind of looks like foam. It insulates like foam at between R 3.4 and R4, depending on the density. Cuts like wood. It's hydrophobic. 100% cork bark. You can see over on the left, bark of cork oak tree. That's the only ingredient. It is carbon negative, and there's absolutely zero toxins. Oh, damn. Well, I would need it to move fast anyways. Um, Watching videos of the cork being harvested is really cool. So basically, cork trees, you take the bark off of, yeah. So you take the bark off the tree and they put it in this big mold that is heated at 660 degrees with steam. And then these big kind of popcorn or larger size granules of cork bark, the sap liquefies, the cork bark expands, and then it holds everything together. Those panels are cut into sheets, or those blocks are cut into panels, and those panels can be used for interior and exterior cladding, very easy to work with. You can do patterns with it. Here's this example's been, probably been out for a year or two, so that's been kind of silvered. This is a project in Alaska. It comes in all different thicknesses. This project has 6 inches of cork on it. This Alaska project is very nice. Project in the UK. Project in Spain. This is a CLT and cork project. It's a really versatile material. And cork actually is the oldest insulation product on the market. This is a diagram from Armstrong, the company that makes acoustical ceiling tiles and carpet. They started as a cork company in the 1860s doing cork like bottle stoppers. They were making expanded cork. This guidebook shows the comparison between other products that people or other things that people were using it as insulation in the 1920s. So we've got sugarcane fiber, vegetable fiber, cattle hair, eelgrass. So this is a product that's been around for a really, really long time. So why did people stop using it? This maybe is the first continuous insulation detail and kind of showing monopoly, sort of monopoly framing style assembly from the 1920s. Project in San Antonio over here on the right. Why did people stop using it? Many companies, including Armstrong, started making insulation with asbestos and really leaned hard into asbestos, which is a magic mineral. It is indestructible. It's fireproof. lasts forever, goes into fiberglass. It may or may not be Ronald Reagan, who's a big fan of fiberglass. You can eat tea and cookies while you're installing fiberglass, and then styrofoam. So these are, marketing from the 40s and 50s. Styrofoam, the superior lifetime insulation. You can lift it over your head. Um, yeah. Again, there are some details of the house. Very flexible material. Hemp fiber, carbon negative US grown material. It's fast growing, resilient rotation crop. Grows 8 feet tall in 3 months. Cons, new and different. Wood fiber insulation, pros, carbon negative, US made, non-toxic material, utilizes waste wood fiber or waste sawdust from sawmills in Maine. It's a carbon footprint home run. They are making loose fill bat and as of the end of this year, board. It has unique performance benefits in terms of its thermal inertia. Main cons, new and different. Here you can see wool, cellulose, cork, hempcrete, straw bale down at the bottom. This carbon impact chart. Here, wood fiber over to the left. 2x6 wall comparison. So if you did I think this is 5,000 square foot wall area. If you did it with open cell foam and then continuous EPS, including the embodied carbon of the plywood and the 2x6s, you'd be looking at 7,000 kilograms of carbon dioxide emitted. If you did that with rock wool and comfort bat and comfort board, you'd be looking at 6,500 carbon dioxide emitted. If you did that with plants, and these are for equivalent R values. If you did it with wood fiber and cork, you would be looking at negative 5,728 kilograms carbon dioxide emitted. So just underlining insulation is a really big opportunity for creating carbon storage without sacrificing performance on projects. The hemp wool kind of over roof installation at this project. So this is how we insulated the roof here using wood fiber board for details over the skylights, adding the roof. Yes. And so then beyond embodied carbon, natural plant-based materials tell a legible multi-sensory story about where buildings come from. So here, just kind of walking through the house, you step up and the cork visually is a very dynamic, very organically textured material. It is hard to capture in photos exactly what it's like in person because there is so much texture and kind of color variety with it. So yeah, here walking through the house, first thing people say when they walk into this house typically is like, wow, like it smells great in here. What's going on? How did you do that? The floor here is finished with the linseed oil. Walls and ceiling are unfinished. The cork doesn't require any finish. So the smell of the house is really a combination of the natural aromatic compounds, the terpenes in the Douglas fir, and then the aroma of the linseed oil, the aroma of the cork, which has a really, really nice scent. Here, moving upstairs, we have a mossy natural wood floor upstairs. Again, just finished with a linseed oil. Um, Here is cross-laminated timber kind of bay window to sit in. But one of the nice things about using these natural materials and having such a simple, here you're kind of seeing the cross section of the wall assembly on axis, or getting to see it, is that these are materials that you can actually touch. The experience of wood, the experience of cork is something that adds this really meaningful level of sensory richness to the experience of the space. It's really the scent, the touch that is what kind of distinguishes the experience of this building. Here, bedroom, kind of going into the bathroom. Yeah, then lots of play with light. This is these kind of glazing between the stairs is facing towards the skylight, so you get natural light from that skylight at times. Again, really flexible to work with. Yeah, this interior barn door, project at night. Yeah, so well. Thank you. Sell natural, healthy building materials. So we sell Amarine cork insulation, Mafia natural wood floors, Alchemist paint. It's a cradle to cradle gold mineral based paint made in North Carolina. Timber HP wood fiber insulation, Carbon Smart wood, Vapro Shield, and Simpson Strong Tie. In particular, their mass timber fasteners. So I'm going to put a video on with no volume in the background that shows, um, let's see, that'll show some video of the house. And then, yeah, open for any questions.
There were a couple in the chat. One was, can it be used exterior finish in a weather area? Was it, which material were you referring to? Not sure if it was.
Yeah, assuming it's the interior, the cork, yes,
Yeah.
the expanded cork can be used in any climate as an exterior finish. We've been through hailstorms here, obviously plenty of heat. Yeah, freezes, but it's stable and has a stable R value at um, the full range of temperatures. And the thing about cork is that it has a closed cell molecular structure. And so it'll max out at a 5% moisture content. If you look at it under a microscope, it basically has a honeycomb cell structure. It is bound together with the natural binder suberin, which is the sap, which is a waxy hydrophobic kind of natural it's a natural hydrocarbon. So yeah, it's basically reconstituted kind of thermally modified cork bark. Yeah, and it's been used in projects from Finland to Australia. It's been used on the exterior of buildings for the last 25 years, and then the product has been around for yeah, the patent is from 1896 in New York. So
You mentioned that it was inexpensive, and I'm wondering for interiors, is there a thin version that would be considered inexpensive to use? Like, do you have to go with the rectilinear pieces, or is there a roll that you would recommend that doesn't cost an arm and a leg?
yeah, so cork is yeah, I think cork is not in a lot of cases is not an expensive material. So when you're talking about interior finishes right now, I sell cork in a 7/16 thickness and then a 3/4 inch thickness. The 7/16 is around 350 a square foot. The 3/4 inch is 450 a square foot. Yeah, and it always comes in that because it's expanded, because it ends up being in that block as part of how it's manufactured, it comes in sheets. So like the 7/16 is a pack of 30 sheets. It covers about 150 square feet, and it's yeah, about 350 a square foot. The sheets are about 20 inches by 40 inches.
Awesome, thank you. There was another question about the cork, the R value of 1 inch cork insulation. Do you know that by?
Yeah, so the cork comes in two different grades. So the MD facade, so medium density facade is R 3.4 an inch. So it's a slightly lesser R value because of that density, it has less air cavities. And then the standard grade cork is R 4 an inch because it has more yeah, more air. So
There was one other question in the chat, and feel free to chime in. Mark asked if you have the square footage and hard cost of construction for this project.
yeah, so building this again here in Austin, this project I've been talking about $550 a square foot. So this project is about 1,000 square feet, so it'd be about $550,000. That is the all-in with fees part of the yeah, that's the all-in sort of with fees. Price. Yeah, the cross-laminated timber on this project was about about $85,000 just for the material delivered to site. Yeah, and this has there's an ERV, there's a dehumidifier, there's a heat pump, VRF carrier kind of AC system, all the wall and it's passive house caliber kind of enclosure enclosure components. Yeah, but I'll leave it at, kind of leave it at that for now. And then also the carpentry costs were significant. A lot of this, the kitchen, et cetera, we kind of built on site. So yeah, that's also kind of a large component of cost.
So Greg, I'm curious, deciding to go with solid wood walls, obviously you negate the need, and with cork, you negate the need for extra labor in terms of the siding. Once you put it on, you're done. And I guess the same is true. You don't have the drywall you have to put up. How did you run your mechanicals if the wall was solid? Was there a gap in the walls for your mechanicals, for your electrical and your plumbing? And I'm just curious in terms of the cost. I would imagine in terms of from an architectural detail and structurally, you have greater flexibility in what you can do because it's solid wood. So you basically got king studs throughout the entire wall.
Yeah, it requires a totally different it requires more planning when it comes to your mechanical, electrical, and plumbing. So like these images here, the return or the register that's up top, that big circular kind of commercial looking register up here, uh,
Mhm.
that is at the top of a vertical mechanical core. So there's a vertical mechanical core that hits the primary bedroom and bath, and then comes up and hits the public spaces. There's a 70 pint DHU under the stair. The return is going through the open treads under the stair. And then the ERV is mounted under the house. And so the duct runs to the ERV are kind of under or hanging off the bottom of the CLT panels, which are elevated. So yeah, that's how the mechanical system works. This sort of shelf that's over the kitchen, or sort of ceiling that's over the kitchen, this kind of light shelf is used to run electrical over to the left side of the building that's shown in this left image. Other electricals run under the stair to where the fridge is over on the right side of the right image. Obviously, there's a framed wall with some kind of thickened kind of columns that, if you can see on the left, like next to some of these like plate bowl thingies, that's where the outlets are. One of these is also this thickened part behind the vent hood is the chase for the vent hood to go down. And then there's electrical running, but behind, there's electrical running in these split spots too. So, yeah, there's a lot of consideration going into how you're creating chases for your mechanical, electrical, and plumbing, and having like service walls and a mechanical core, etc. The plumbing vent also is happening in this vertical mechanical core. Um, and the way that this was resolved, obviously I like it. Like I think it worked really well with the architecture for this project. But it's a level of planning that's different than your typical project, because usually you've got plenty of cavities to stick stuff in, so you don't have to think so hard about it.
That's
And did
fabulous.
you
I'm
do
sure
like
the
a calculation
inspectors.
price wise in terms of solid walls versus building panels with insulation on the inside, with natural insulation on the inside?
Um, I don't. The solid walls from a material perspective, and so you guys could figure this out on your own, or somebody might know, but the solid walls from a material perspective are going to end up being about $15 a square foot for that roughly like 4 inch thickness. Depends on the price of wood at the time, but yeah, it's like maybe you get 13, maybe it's closer to 17, but like 15 is a good average. Yeah, so um, for me, if you're, yeah, part of this kind of as an experiment or a case study, yeah, these panels again, like are not, the walls and ceiling aren't finished. They're not painted. Like, there's a little bit of sanding touch up in a couple places, but what we put in when we installed them is largely what's here now. So at the time, I was really interested in having one trade. Basically, we had one trade who installed that cross-laminated timber panel and then installed our air and water control layer and then installed the cork. That was all kind of carpentry. Typically, doing houses here in Austin, we would have if I come from the inside, you would have a painter, you'd have a drywall person, you'd have a trim person, you'd have your insulation subcontractor, you would have your framer, you would obviously have like plumbing and electrical, at least usually in the exterior wall. Then you get to the framer with the sheathing and sheathing, siding, etc. And then you get the painter back on the outside. So trying to keep all of that within a single trade was part of the experiment with this.
There's a
Um,
couple questions here. When using CLT, one of the things
Thank you.
that Alex noted was that there's gaps and other construction tolerances possibly showing. So for you, to make sure that those gaps and cracks are not unsightly, were there any tricks or did you find that they just blend right in?
yeah, I think yeah, the tolerances between panels here were about 16ths of an inch. Panels that are made in the US are typically not edge glued, so the board, but in between boards, things usually open up a little bit. Doug Fir in particular has a propensity to check some. There's plenty of checks around, but yeah, I think one of the big differences in terms of how you experience the space visually is that there's wood grain everywhere. So there's so much pattern. There's so much pattern. The color is dynamic, and you're not as prone to. And I've built houses in Austin for like 15 years, so. Yeah, anybody who's been building houses understands like the drywall and paint punch list part of the end of a project. And it's fundamentally very different than painted drywall or a synthetic kind of surface, where painted drywall is supposed to have this very even color because you're putting this kind of film of latex paint on top of a wall that is one color. With wood, you don't, when you have it on the scale of a whole space, the cracks, etc., do not pop out to you. I mean, a very occasionally, and I've had literally thousands of people through this house since we've done a few of these AIA tour kind of deals. Um, yeah, every once in a while, I've had one architect who's like, "Oh, these finger joints between the boards. It would be nice if we didn't have the finger joints." And I'm kind of like, "Cool." But the other thing too is people are so blown away by the way that the house smells. And they immediately, people usually walk in and they're like, wow, like smells like, wow, basically like what the fuck is happening? I'm not used to having a house smell good. And then they touch the wall, usually within like 10 to 15 seconds. Because you just intuitively understand, like, oh, like I can touch this. And the same thing happens with cork too. People usually come to the front door and they're like, they'll put their face close to the cork and they'll touch it. Um, because like natural materials, like visually, tactile, etc., are way more interesting than synthetic stuff. Like it's not even close. Like
I have a
because
couple of more questions about them, actually. So
sure.
for the cork, for repairing it or touching it up, do you have any tips, for having it match? Should owners purchase, extra stock? But I mean, I don't know if you've had to touch it up. It's not used on any of the floors, right?
Yeah, it's not used on the floors. Yeah, it's not like a typical use for the floor because it's a little bit, a little bit too soft. Or it is too soft. But let me see. Um, oh, can y'all see? Am I big for some
Yep.
of you guys now?
Yeah.
Yeah. So, like here, like this. Yeah, right here. Like this has a patch from here to here because this is like where people are kind of coming in and out. But this is one piece, this is another piece, this is another piece. This is several different pieces. This, let's see here. Like this corner, I mean, you can actually just cut out and have like a clean patch, but this corner got hit by a mini excavator, and I was able to just find this piece on the ground. They're like two or three pieces, and glue it back in here with Tite Bond 3 and a bunch of cork dust. But it has so much pattern, it blends better than, and I don't think I'm exaggerating, but it just blends better than anything else you could possibly use on a house because there's so much pattern. Like it's just, it's not like one continuous color. If you put a
Mhm.
new panel up, it'll be obviously a different color for a little while, but after 6 to 12 months, depending on your UV exposure, yeah, it'll end up blending.
I have a question about glue, actually. Any
Yeah. So
recommendations
like
for setting?
here, this is a this is a patch piece. This is a patch, that's a patch piece, but you can see it's very difficult. I mean, I don't know how to get a camera is decent on this computer, but
It's
uh
accommodating. It
yes.
accommodates. Do you have any recommendations for setting requirements for glue used in CLT to avoid VOCs, or is this a non-issue?
Um, it's It is not I mean the CLT manufacturers that I work with all have kind of declarations of like what is in, kind of what is in those glues. Those glues are applied at kind of applied at the factory. Yeah, I think they're using really, really good glues. It would be nice to not have the glues. There are like dowel laminated or nail laminated timber mass timber options. But for me, the decision I made personally is, or professionally or whatever, is the larger picture kind of being able to store that carbon and using smaller diameter wood from domestic forests to replace kind of higher carbon materials, I think is broadly like a really is a win.
Yeah.
And the glue itself is around, I mean, I think it's less than 1% of the overall volume of kind of the overall volume of the board. And it's a very easy, this is a very easy way to have a natural wood surface on your interior. And that wood is always absorbing a little bit of moisture, releasing those aromatic compounds that there's tons of scientific studies about the kind of positive effects that aromatic compounds in wood have. Yeah.
That leads me to a question about whether or not cork was applied to the underside of the floor, or was the mass timber alone with weather barrier sufficient for performance?
Yes, there's an inch and a half layer of cork on the underside, and the assembly is effectively the same. It's in this case 5.5 inches across laminated timber, self-adhered air and water controlled layer, and then an inch and a half of standard grade cork.
That's awesome. And I know we're running out of time, but do you by chance know what the monthly energy bill looks like? Is there rooftop solar?
That's a good question. Let's see here. I mean, we have two houses on this on this meter, but let me check. I don't know if you want to ask another question while I'm doing this, but I'm gonna try to log on to my I'm gonna try to log on to my energy monitor, but it's making me actually like log on. So
We could send it out to guests if you want later. So no pressure. One specifically said an EUI calculation might be nice, but that could
yeah,
be later.
I have the I can tell you the kilowatt hours that we're using for this house for everything major except for water heating. So yeah.
That's awesome. Have you ever put lime plaster over cork? Like, let's say you want some
I
color.
haven't personally, but yeah, putting plaster, there's kind of an ethos system that they use there's an ethos system that they use very commonly in Europe. And we've had other people kind of experiment with it, but yeah, they use cork, and in that case, the cork is your continuous insulation and your kind of drainage layer. Because cork is a drainable like water drains within the thickness of the cork. It's not going to be comparable to like a quarter-inch drainage gap, but it is a material where there's some gaps in between these kind of cork granules, and water drains out of it.
If you
So
wanted color on your cork, how would you recommend doing that?
we've had good success with Alchemist, the mineral paint that I represent, like kind of using that on the exterior. And that the primary binder there is quartz. It's a potassium silicate is the base of the paint, and then it has different mineral pigments to give it, kind of to give it the colors. But basically, that almost forms like a thin kind of layer of plaster on top of it has more of a plaster kind of tactility rather than like a stretchy kind of plastic tactility of latex paint.
Okay. I have one last question, or there's actually two on here. Do you still have time?
Yep, I'm good.
Okay. And I did put a link for AIA credit on. There's a link in the chat. There's a forum for you all. Um, so one question was, have you built any houses with hempcrete insulation?
I haven't built anything with hempcrete yet. Hempcrete's very cool. Yeah, I mean, I think one of the reasons I liked just decided to go down this kind of cross-laminated timber road is that it allows for factory fabrication, which when I was doing this 5 years ago, yeah, it's like I've been in some of these factories now, like you have big panels, they have the robots cut them, everything can fit together, it ties into your digital model. So that's something that you can't do with you can't really do with hempcrete. I mean, there's some people kind of experimenting with, I guess, hempcrete panels that are sort of similar to the straw insulated panels. The straw insulated panels are kind of probably a little bit more exciting, but hempcrete, one of the challenges is just the weight, the like heavy kind of like, rammed earth, all that stuff. It's just heavy, so it makes more sense to do it on site. So.
Awesome. And then have you, if you've had straw panel assemblies available in Texas, and you were doing a house with similar carbon goals, would you pursue straw panel instead of CLT? And
Straw's
how?
definitely, yeah, straw's the shit. Straw's the best. So
How would you
yeah,
choose? Given
yeah, I think yeah, I mean it's just a matter of it'd really be a matter of logistics and kind of cost. Yeah, I mean straw, because it is a waste, or it's like an agricultural residue, or like it's a waste stream carbon. Whereas yeah, wood is something that's harvested, and I do believe in, there's lots of debate around it, like in terms of like, oh, like the wood, like I think it's important for people, as our, in our part in nature, to be in forests, see what's going on, and we can harvest trees in a way that is good for the forest. And we've gotten a lot better at doing it. Like, anyways, yeah, but straw, I mean, most of the time we haven't been using that stuff for anything. So, and it grows everywhere, and it grows fast, and it takes a lot of carbon. So yeah, like straw is awesome. Yeah, no, nothing bad to say about straw.